Hello and welcome back to my channel. Today we are going to discuss another past year paper from October-November 2020 970961, that is Probability and Statistics 2 S2. That is paper 6 now. So let's discuss question number 1. Here is question number 1. It is known that on average 1 in 300 flowers of a certain kind are white. A random sample of 200 flowers of this kind is selected. Use an appropriate approximating distribution to find the probability that more than one flower in the sample is white. So it's like on average, and every particular event is independent of each other. So we can approximate it by Poisson, and for that the thing which is given is going to be n is given as 200, and probability proportion is given 1 over 300. So from here we'll get the parameter of Poisson distribution, that is lambda, and this is going to be np 200 over 300, that is 2 over 3. Now we have this, we can take x as the number of flowers which are white as norm Poisson distribution with 2 over 3. So our question becomes finding the probability dot x is more than 1, x is greater than 1, and we can solve it by 1 minus probability of x is less than or equal to 1, that is 0 and 1. So it would be 1 minus e raised to the power minus lambda 2 over 3 times 1 plus, for 1 it is lambda to the power 1 over 1 factorial, so it is only 2 by 3. So this become 1 minus 1 plus 2 by 3 is 5 by 3. So 1 minus 5 by 3 e raised to the power minus 2 by 3. Now we will calculate this value from the calculator, and it is 0.1443 and so on. So till 3 is significant figure, this is the probability 0.144, that is 14.4%. Let's do the next part. Here's the B part. Justify the approximating distribution used in part A. So we will focus on two things when we approximate anything by Poisson. First thing is n should be large, more than 50, and here it is n was 200, so it is of course greater than 50. So this is the one case we can approximate it by that. Another is this np means lambda, that should be less than 5, and it was 2 by 3, which is of course less than 5. That's why it is this is the correct approximation. And here is the next part. The probability that a randomly chosen flower of another kind is white is 0.02, and a random sample of 150 of these flowers is selected. So here also we can see the probability is given 0.02 and 150 is the random sample. So lambda in this case would be 150 into 0.02, that is going to be 3. So again it would be, we can use the Poisson because it is again less than 5, and the random sample size of the sample is for more than 50. Now the question is, use an appropriate approximating distribution to find the probability that the total number of white flowers in the two samples is less than 4. So in the previous sample it was x as Poisson with 2 by 3. We can take this as, let's say, y as again Poisson with 3 as the parameter now, and then we will take this total, then we can make another random variable as x plus y, and we can only do this x plus y in the Poisson because only the sum is defined for Poisson. Now this will also be a Poisson distribution with the new parameter as the sum of the previous parameters. So now it means here the lambda become 2 by 3 plus 3, that is 11 by 3 here. So the probability is z is less than 4, which is going to be probability of z is equal to 0, 1, 2, 3, and now we will use the formula, and that is going to be e raised to the power minus lambda multiplied by 1 plus lambda over 1 factorial plus lambda square over 2 factorial plus lambda power 3 over 3 factorial. Now let's calculate this. This value is e raised to the power minus 11 by 3 multiplied by 19.6049, so I write 5, and finally we'll multiply this with e raised to the power minus 11 over 3, so the final answer become 0.50113, so 501 till 3 significant figure. So that's the probability, that is 0.501, or we can say 50.1%. Let's discuss the next question now. Here's the second question. In a survey, a random sample of 250 adults in a Fromley were asked to fill in a questionnaire about their travel. It was found that 102 adults in the sample travel by bus. Find an approximate 90% confidence interval for the proportion of all the adults in Fromley. So this is not given that it is a normal distribution, so we'll use the CLT. We'll use CLT to make it approximately normal so that we can work for 90% confidence interval, and we know if the 90% confidence interval is there, so this value would be, we will get for 95, because 90% means 5% here, 5% here, so total become 95. So for this 95, z is 1.645. so we'll write here for corresponding z is going to be 1.645, and since we are talking about proportion here, so PS is 102 over 250, and this gives QS as 250 minus 102, that is 148 over 250, and this confidence interval would be PS minus z times root PS QS over n, and PS plus z times root PS QS over n. That is the formula from the formula booklet also we can see, and we'll calculate this. It means we are going to calculate, I'll calculate this separately, this whole value, so that we can get it easily. So first one, z 1.645 into root 102 upon 250 into 148 upon 250 upon 250. Let's calculate this from calculator now. From calculator we can see this value is 0.05113 and all. So the confidence interval CI become 102 upon 250 is 0.408 minus 0.05113, so no need to write that, and comma 0.408 plus 0.0511. So this value will be 0.0511. We subtract and we got lower limit as 0.3569 and the upper limit 0.408 plus this is 0.4591. Finally we'll write till C significant figure. That value is going to be 0.357 comma 0.459. that is the confidence interval, 90% confidence interval. I hope it is clear. Let's do the next question now. Now here is the B part. The survey included a question about the amount X dollars spent on travel per year. The results are summarized as follows: n is equal to 250, sigma x is equal to 50,460, and sigma x square as 19,854,200. Find unbiased estimates for the population mean and variance. So unbiased population mean is also same as the mean, and it is going to be sigma of x upon n. So it is 50,460 upon 250. So we can directly calculate. It is 201.84. We can write till C significant figure also as 202. And unbiased mean as unbiased population variance is denoted by S square, and this is n over n minus 1 sigma of x square upon n minus population mean whole square. So we can calculate by this. It is 250 over 250 minus 1, 249 times 19854,200 over 250 minus 201.84 square. Now we'll calculate this value from calculator, and this value is 38,832.745 and so on. So we'll write till C significant figure, and that is going to be 38,800 only. That is going to be the value, and it is, since we are talking about this amount, so we can put this as dollar, this dollar, or the final one again, $38,800. Let's discuss the next question now. A counselor wanted to select a random sample of houses in Fromley. He planned to select the first house on each of the 143 streets in Fromley. Explain why this would not provide a random sample. First one is, it is certain that there are some houses with, so we'll write maximum of the houses as like has less chance of being selected, and so we can write every house doesn't have the equal probability. Every house doesn't have equal probability of getting selected. So we can add anything like that. Let's discuss the next question now. Here's the third question. The masses in kilograms of female and male animals of a certain species have the distributions as normal. 102 and 27 square are the mean and variance respectively, and the same for male. So we can write F for female as normal distribution as 102 mean and 27 square as the variance, and male, same for male, normal distribution with 170 as mean and 55 square as variance. The question is, find the probability that a randomly chosen female has a mass that is less than half the mass of a randomly chosen male. So it means we want to find the probability of probability in the case when F is less than half of the mass of randomly chosen male. So we can take this as we can define another random variable as F minus 1 by 2 m, and we know that any linear combination of two normal distributions is going to be a normal distribution, so it would also be a normal distribution, and we'll find the probability of this. So let's define this as another random variable. I'll take it as x would be normal distribution, and for that we require the two parameters. So first of all, mean is going to be expectation of F minus 1 upon 2 times m, that is 102 minus 1 upon 2 times 170. So 102 minus half of 170, that is 17 now, and variance sigma square would be variance of F minus 1 upon 2 m. We know that in variance we never subtract, so it is going to variance of F 27 square plus 1 upon 4, 2 square here, 1 upon 2 square, 1 upon 4 times 55 square, and this value is 1485.25, and now we will write it here 17 and 1485.25. so our probability, that is this probability would be like probability of x is less than 0, and probability of x is less than 0 would be probability of z less than 0 minus mu, that is 17, over sigma. Sigma is the square root of variance, so it is 148.25 for 1485.25 square root of it, and this value is going to be probability of z less than 0 minus 0.4411 and all. And we know, if we see the distribution graph, this value is going to be here minus 0.441, and we need to find this value, and of course we'll find the corresponding value here with the positive 0.441, and this is going to be 1 minus phi of 0.441. and now we'll see the distribution table, and from distribution table we calculate, and this value is going to be 0.330 and all till 3 significant figure. That is the probability. I hope it is clear. Let's do the next question now. Here's the question number 4. The diagram shows the probability density function PDF of a random variable x for x between 0 and a. Fx is equal to k, elsewhere fx is equal to 0. Express k in terms of a. So first thing, we know that minus infinity to infinity fx dx is always going to be 1. total probability is 1. So here otherwise it is 0, so of course we'll calculate from 0 to a. Fx is k dx, and it become k times a, because x and the upper limit is a, so a only would be 1, and hence the k value is going to be 1 upon a. We could have directly written, because we know that this area should be always 1 and length is 1 a, so width should be 1 by a only. So k value is 1 by a. Now let's discuss the b part. Given that variance of x is 3, find a. So in this case we know what is variance. Variance of x is given as expectation of x square minus square of expectation of x. So it become, from the formula, it is 0 to a x fx dx, and in place of x it is expectation of x square, so it would be x square fx minus square of integration from 0 to a x fx dx whole square. So we need to calculate these two integration. First one is 0 to a x square fx is k dx, so it become k is 1 by a, so 1 by a came outside, and it become x square integration, that is going to be x cube upon 3, and the limits from 0 to a, which would be 1 upon 3 a cube upon a, that is of course a square upon 3. And for the next one, 0 to a x fx means x k dx, and k is 1 upon a from the first part we have seen, so it is going to be integration of x with respect to x with dx, so it is going to be x square by 2 and x square by 2, and limit is again 0 to a, so it become 1 upon a into a square by 2. This got cancelled and we are left with a by 2 only. So variance, now we'll substitute these values, and that is going to be a square over 3 minus square of a by 2, that is a square by 3 minus a square by 4, and it is upon 12. 4 minus 3 is 1, so it is a square by 12. So variance is a square by 12, but given that variance of x is equal to 3, it means a square over 12 is equal to 3, means a square is 36, hence a would be positive 6, because a2 is lying on the positive x-axis, we have to ignore minus 6, so that is the value of a. I hope it is clear. So that's it for this video. We'll discuss the last two questions in the next video. Till then, thank you so much.